Hello and welcome to our video on histograms for continuous numerical data. In the previous example, we worked with discrete numerical data. Remember that discrete data is data that it can take on a limited number of values. It is usually the result of a counting or numbering process. In this example, in this video, we're going to look at making a histogram for continuous numerical data. Remember that continuous data can take on an infinite number of values and is usually the result of a measurement process. In order to do this, we would need to create classes or intervals for all of our values. So we can divide our data values into classes, and the approximate class width would be the distance between the largest value and the smallest value divided by the number of classes that we want to use, as described here. So basically, we just want to figure out the range of the values, largest minus smallest, and divided by the number of classes. These classes cannot overlap, so therefore we must always round up. Generally speaking, the number of classes is best to be between 5 and 10 total classes. Depending on your data, sometimes more, sometimes less, but usually 5 and 10 is best. I will never make you create one of these. I just want to talk about how we can make them if we need to. But most of the time, we're just going to be analyzing histograms that have already been given to you. The class width is the difference between two consecutive lower class limits, and I'll show you this in an example on the next page once I get there. The class mark is the class midpoint. It is the middle value in the interval, which is used as the representative for the class. To find the class mark, we're just going to take the upper class limit of the class plus the lower class limit of the same class and divide it by 2. Basically, we're trying to find the average or the mean or the median or the middle value. And again, I'll show you that with this example. The last definition we need to talk about is the class boundary. The class boundary is the midpoint between the upper class limit of one class and the lower limit of the next class. We're going to use the class boundaries as x values to ensure that our bars will touch on a histogram. Recall that histogram is used for numerical data, and we use histograms because the numerical data will always overlap, or not overlap, but they'll always follow the specific order, and the first value is always followed directly by the second value. So we need those bars of the histogram to match up and be touching. All right, so in this example, we want to fill in the missing limits and boundaries and then create a frequency histogram and frequency polygon for the data and answer the questions that follow. So we have the class limits. Well, first we should start with the class width. What is the class width? The class width is the distance or the difference between two consecutive lower class limits. So the difference between 65 and 58. 65 minus 58 is 7. Most students will get this wrong because they'll look from the lower limit to the upper limit, and they'll think 58 minus 64 is 6. However, if we were to write out all of the numbers, 58, 59, 60, 61, 62, 63, 64, we'll see that we have 1, 2, 3, 4, 5, 6, 7 total numbers in this first class. We need to include the boundaries, or we need to include the upper and the lower limits in our counting. So the easiest way of doing this is, again, to just subtract vertically between two consecutive lower class limits. So if we continue with this same idea of subtracting or adding vertically, we can add 7 to the 85 to get 92, add 7 to the 92 to get 99, add 7 to the 99 to get 106. We can add 7 to the 86 to get 93. We can add 7 to the 93 to get 100. I'm going to remove those plus 7s just so we don't muddy the waters here while we're working. You'll also notice that the number immediately after the 92 is 93. The number immediately after 99 is 100. So we're not skipping any values. Our class boundaries will be the midpoints between each of these values. So if you look here, the number between 64 and 65 is 64.5, so that will be the class boundary. The number between 71 and 72 is 71.5, so that is the class boundary. So now we need to look for 78.5 will be the lower class boundary of this fourth class here. We need to look for the value that is between 85 and 86. Well, the number between 85 and 86 is 85.5. Just going to make that look nicer. The number between 92 and 93 is 92.5. So 92.5 will be the upper limit of this fifth class and the lower limit of the sixth class. If we add 7, we'll get 99.5. So 99.5 will be the lower class limit of lower class boundary of the final class. And the class boundaries always need to get extended beyond the maximum value. In this case, 106 is the maximum value. If we extend beyond that, it would be 106.5. The class mark is again the midpoint of the data values. In this case, we are looking for the value that is between 58 and 64. What we can do here is add 58 plus 64 and divide by 2. If we were to do this, we would get 61 as our class mark. Also, we can use the fact that we know that the class width is 7, so each of these differences should be 7. But just for practice, we'll do this again. 79 plus 85 divided by 2. If you do this along with me in your calculator, you'll get that the class mark is 82 for the fourth class. 86 plus 92 divided by 2. Again, following along with me, you should get 89 for your class mark. Another way of thinking about this is 89 would be 3 above 86 and 3 below 92. So it would be the midpoint. I'm just going to fill in the last two here. Again, 93 plus 99 divided by 2 will give us 96, or again, we could add 7. And the difference between 100, or the middle number between 100 and 106, will be 103. From here, we will learn how to graph these histograms for this continuous data in either the Texas Instruments TI 83 or 84, and also in GeoGebra, but I'm going to make two separate videos for those describing the calculator steps. Thanks for watching.